All right, ladies and gentlemen, hi, I'm recording, so I'd like to get started. So this lesson differs from yesterday by what I'm going to ask you to do is I'm going to give you a function, and I'm going to ask you to take the square root of that function. Okay, you guys ready for that? Okay, all right. So there's a couple of ways to do it. So right here, we're going to graph this function. So we're going to graph the original. What kind of graph is that going to give me? Linear, speaking of grade 10, right? So we're going to graph this. It's going to be super exciting. Super exciting. You ready? Why are we not ready? You're going to... Oh. Why are you looking at me? We're going to graph a straight line and we're already stressed. Because what's the degree on the highest exponent on this equation? 1. So anything that has a degree of 1 is going to result in a linear function. If it has a degree of 2, so the highest exponent is 2, it's a parabola. Okay, so that was grade 10, was linear. Grade 11, we did a lot with parabolas. And now grade 12, it's everything. We're going to be doing cubic functions, quartic functions, quintic functions. That's all in chapter 3. And it's actually really easy if you can graph a straight line and you can graph a parabola. Quintic, exponent of 5. Okay, do you guys remember this? Okay, y equals mx plus b. This is in the reverse order though. I could write it like that if that's better for you. So what does that tell us? Y-intercept is at 3. And what's my slope? Down by 2, right 1, because this has a denominator of 1 here. So down 2 to the right 1, down 2 to the right 1. And we should end up with a linear function. Oh, that does not look like a straight line. What did I do? What did I do? I stopped going down by 2s, I went down by 1s. Everything was good. Silly. I didn't use an erasable pen. Okay, let's try that again. 1, 2 down, 1 over. So I'm here. That looks better. Yeah, it can go on for infinity. Okay, how do we feel about that? We feel okay about that? All right. Okay, we still have to do the other one. So we've done that one. Good job, everybody. Okay, so now you have a function on the page, and now I'm asking you to root it. All right. So what's under the root sign? F of x. What letter does that represent? Y. All right. I see the excitement in your voices. Okay, so that means we're going to square root y values only. And we did this in our other table, right? Like we were good with that. Right? Yeah. Okay. So what do we know about these y values down here? They're negative. Can I square root them? No. So this part of the graph, doesn't exist. No. Okay. All right. So where would my root graph start? What would be the first y value in which my root graph would start? 0. Can I take the square root of 0? Yes, I can. I'd get 0, right? So the question is, at what point, what x value is this graph at 0? 1.5. So what I'm looking for here, and what is that on the graph? That's the x-intercept, right? So the x-intercept is going to be the starting point of the root graph, because that makes sense, because that's going to be the very first value that we have, right? Everybody agree with that? Okay. Super excited. Can we calculate that? Can we calculate the x-intercept? Yes. So if we go up here to this, what do we know the y value is? 0. So I've got negative 2x plus 3. So I'm going to have 3 over 2 equals x, so that's 1.5. So brought my 3 to the other side, negative 3, divide by a negative 2, positive 1.5. Is everybody okay with that? Would this be better? Okay, so there we are. Maybe a table of values might help, because table of values are always helpful. So my graph is going to start at 1.5 and my y value is 0. My next, so I'm using my red pen, so you guys can't see that. I'm just doing these values here. So when x is 1, what is y? 1. And when x is 0, what's y? 3. Sure. Okay. Okay, so now let's do our square root. So we know that's going to be 1.5 and 0. What's this one going to be? 1 and 1. And 0 and root 3. Not terrible. We can use our handy-dandy calculators. Yeah, I will let you. Okay. All right. Okay. Well,
how did you get the 1 and 1 and 0 and 3?
The 1 and 1, it was this point on this graph. And then the 0 and 3 is that point. And if we're only square rooting y values, so the x's all stay the same, the square root of 0 is 0, square root of 1 is 1. It's just root 3 that causes the problem. Anybody know what root 3 is? 1.73? Okay. So what shape between the first 2 points should there be? Bubble. So this is going to be like here. You guys would agree? 0 and 1.73 would be right here. 1, 1 is still right there. And so we know between the starting point and the next point, we should have a bubble. How do you feel about that? My bubble was a little bit exaggerated. It probably shouldn't be that big. I had a good bubble day yesterday. Today, not so much. Okay. So what points are going to be shared between the function graph and the root graph? What points are shared? What points are invariant points? Remember what invariant points are? They don't change between the parent graph and the transformed graph. So which ones are those going to be? So it's going to be where my y is 0, and it's going to be where my y is 1, because those are the only two values that when I square root them, they're the exact same. Everybody understand that?
Yeah.
Okay, good. Okay, domain and range. Let's do the red one first. Domain of the red one. Sorry, I drew it in red pen. Yep. And what's the range? It's Basil. He's just like shooting off the answers today. It's all right. Domain for the rooted graph. Okay. Basil, wait. Proud of you. Yes. But it's inclusive of 1.5, so we're going to slap some square brackets around it, right? Range.
Infinity to 0?
Okay, switch those around.
Oh, 0, yeah.
And inclusive of 0, right?
Yes.
Okay. All right, good job, everybody. Let's call... We just talked about it, right? Actually, no, I think I leave the relative locations. Okay, or leave the invariant points. Okay, let's talk about some things here. We wrote it all on this graph up here. So the domain of root f of x consists only of the values in the domain for which f of x is greater than or equal to 0. So what does that mean? Y values are positive. But you guys already knew that from this. You already decided that because we can't square root negative numbers. Okay, so then the range consists of the square root of the values where root f of x is defined. So that just means that our range all of a sudden gets limited because we had to put this rule on it, right? It used to be negative infinity to positive infinity, but we had to drop this negative infinity because we can't square root it. That's all that's saying. So this has nothing to do with invariant points. I just got excited. Let's talk about the invariant points again. Should we make a statement about them? So the invariant points will be where?
Always?
Well, because what's the square root of 0? Yes. Sorry. Sorry. Getting in trouble. Getting in trouble trying to explain it. Never mind. Okay, are we good to flip to the next page? Okay. Not yet. Not yet. I like it. All right. Okay. How do you feel about this? Do we need to graph them? Could we do a rough sketch just so I can see them? Yeah. Thanks. No, you don't have to, but I have to. Okay? So when I look at this, I'm going to rearrange this. This is going to be negative 1/2 x squared plus 2. I just flipped the order. That's all I did. I just changed the decimal into a fraction. I felt wild and crazy. Okay, so where's the vertex?
Negative 1 and positive 2?
Okay, what's in the brackets with the x? Nothing, so 0. And then my k value of the vertex is the thing added on. So my x value is 0, my y value is 2. So which way does my parabola open? Down. So this is at 0, 2. And we know it opens down because of there's a reflection in the x-axis because it's attached to the y. We didn't talk about parabolas as transformations, but really you already have done all the transformations to your parabolas. Okay, all right. So let's talk about the domain and range of that graph. What's the domain of that graph? Okay. Let's talk about range. Okay. All right, what do we know cannot exist on the rooted graph? So we know that those don't exist, right? So what do we need to do? What do we need to do? We have to find the x-intercepts. Okay. Oh, you're pulling out the quadratic formula. I like it. I'm going to solve it a different way, though. Do you want to do the quadratic formula?
No.
Well, the quadratic formula is good because it will always work. The way I'm going to show you is going to work because I don't have a b. I don't have a bx, like I don't have a b value. Okay. I'll show you the other way. Okay, that's the quadratic formula. So a is negative 0.5. B is 0 because there is no value attached to an x. So like it's ax squared plus bx plus c. Like that's the format. And then my c value is going to be 2. That's the way I would do it, but it would only work in a situation where you don't have an x. As soon as you have an x, you get a factor. I mean, you could common factor with the negative 1/2, then you'd have a difference of squares, and you'd also get the same answer there. So you could solve it algebraically, you could factor it and solve it, or you could use the quadratic formula. This one you should be able to do without.
If we
Okay, yeah?
if we just put in a 0 for y.
Yes, that's exactly what Madison just asked me.
Yeah, but if there's 2 x-intercepts, how are we find those? If it doesn't only get 1 intercept.
You have to be smarter than your calculator.
You can only get 1 intercept, right? Oh, yeah, okay.
Okay, so negative 4 times by a negative 1/2. Positive 2 times by 2. 4, good job everybody. And 2 times by negative 1/2? Negative 1. So we have one answer that is 0 plus root 4 divided by negative 1. And I'm going to tell you why you can't, because of that. What is the square root of 4, everybody? 2. Good job. Proud of you. How did I get what? Okay. What is the square root of 4 again? 2, but this time it's 0 minus 2, so my answer is going to be negative 2 here. So that's why I didn't want to get rid of the 0, because I think you guys would have dropped that negative sign in front of it. Okay, so the quadratic formula will always work, no matter if you have a trinomial or a binomial. No, it won't work if you, it has to have an exponent of 2 in order to do this, because then you can't factor it. This is how I did it. I said I'm finding my y, my x-intercept, so y is 0. Was it plus 2? Yeah. So then I've got negative 2, negative 1/2 x squared. So I'm going to times both sides by 2. Oh, pardon? So I get a negative x squared equals negative 4. So x squared equals 4. What am I going to do? Square root. So x is equal to, what's the square root of 4? Or negative 2.
The plus minuses are gonna be my down.
Okay, so this way has some limitations here to do it, right? Or I could have done this. I could have had the 0 equals negative 1/2 x squared plus 2. I'm going to common factor that negative 1/2, which would leave me with x squared minus 4. And that's a difference of squares. And then you're going to set each factor equal to 0 and solve from there. So there's many ways you can do it. But really the moral of the story is, okay. What happens to this point though? So I'm going to go back to my red graph here. So these points are shared. What happens to this point on the root graph? It's not gone.
Gets rooted.
What do we root? Do we root the x's or the y's? The y's. So this is going to... So to do the root graph, what did I do on my last page? I square rooted all the y values. What are the y values here? They're 0, right? Yes? So what's the square root of 0?
0.
So shared point, right? Invariant point. What's the y value is 2 here, so I square rooted it. I know that the root of 2 is less than 2, so it's going to end up like squishing it down. So that red graph on mine is my radical graph, and it does not cross the x-axis. Domain and range. Well, we did the domain and range on the original one already. So now we're doing the root graph. So we're doing this one. So looking at the pretty picture, my domain starts where? Negative 2. And it goes to positive 2. All right. What about range?
0 to positive 30. Oh, wait, yeah.
Because does my graph keep continuing up, 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 up forever? No, because it's got that vertex, right? It's got a maximum value. All right, I love you guys. Okay, you ready to draw the next picture? Okay, let's draw the next picture. Yep. Where's my vertex? 0, 5. Good job, everybody. Okay, which way does my graph open? Up. Okay. Because remember that the quadratic formula and your h and your k represent your vertex. And there's nothing in brackets with the x, so we know it has a value of 0, and then the constant that added to it, so 0 and 5 would be my vertex. We know it opens up because a has a positive value. Okay, that's grade 11 in a nutshell. Look at that. Done. Okay, let's do domain and range. Range? Thanks.
Oh my god.
It's a good thing Tripat's here. But everybody understands that, right? Like, that makes sense to everybody? Okay, let's talk about do I have x-intercepts? Do I have negative y values? No, so all of these are going to be fair game. They're all going to be rooted, right? Okay, what's the lowest point on my graph? Right here, right? Like my vertex is my lowest point. It's the minimum. So this point's going to move to 0 and root 5. Because we're square rooting all the y values, right? Everybody with me? Yes? We're square rooting all the y values?
But we would actually square all of them.
No, I don't think you got time in your life for that. But you just know that square rooted values will be less than if it were as a whole number. Like the root of 8 is less than 8. Right? Does that make sense to everybody? So essentially your graph is moving down, and weirdly enough, it's getting a little bit flatter. Okay? You don't have to. Our minimum point is the most important point. Because where is this going? It's going still up to infinity. We're just going to take a little longer to get there. Okay, so domain for this graph. Yep. Range? Yeah. Because there's no x-intercepts, so we don't have to do any of that junk. We have no negative y values, so we don't have to worry about that. Okay? So there's no real restrictions on this graph except for that lowest y value. So do you see how the little pictures kind of are helpful? They kind of are. Okay. All right. Where's my vertex? 0 and negative 2. Oh dear. What does this mean? X-intercepts. So let's take the time right now and find the x-intercepts. You can totally do quadratic again. It's not a perfect square. No, a is always on the x squared. 1. What's b? 0. C? Negative 2. B comes before the x. Like it's the coefficient on the x.
So A is...
In this one, it's going to be A is 1, B is 0, and C is negative 2.
So it's just plus minus root 2?
Yeah.
Are we going to do the quadratic formula to figure that out?
I'm not, but everybody else is.
Oh, okay. I don't have to do this though.
You don't have to, no.
Yeah, I know, right? Yeah.
Yeah, like, just remember the plus minus, but if you have the picture, that will help you remember that there has to be 2. So the picture is kind of helpful for that.
Okay.
Just trying to sell the picture. I just left them as exact values. I left them as roots.
Well, how did you get that? Like, I don't understand.
It should be root 2. Plus minus root 2.
Oh, boy. Can you do it? Can you do this? Oh, I got root 8 over 2. Same.
Okay? Yep.
And then what?
So simplify your root.
By doing what?
So you got that as an answer? So now we're going to simplify our radical. What factors of 8 have a perfect square in them? 4 and 2. So this would be the same thing as saying root 4 times root 2 over 2. What's the square root of 4? And then what are you going to do? So much. So much.
Isn't that
That
messed up?
is, like, when we get
Root
those
A is
accents-
not the same as root two,
What?
because that's like the equal sign.
What?
They are all equal.
They are?
Yeah.
So
So
root
it's
three
negative
is
root
the
two and
same as
positive
root
root
two?
Yeah.
No,
Pardon,
root
Trevor?
eight is the same thing as 2 root 2, and it's the same thing as root 4 root 2. These are all.
They're all equivalent.
Yeah.
Oh.
They're all equivalent expressions for the same number. Like if you put this in your calculator, you'll get the same decimal as if you put this in your calculator. You'll get the same decimal if you put that in your calculator.
Yeah, but we reduced the two though.
That's okay. It's like saying 6 divided by 12 is equal to 1/2.
Oh, okay.
Like we reduced it, but if we actually turn them into decimals, they'd have the same value of 0.5. So I can say they are equivalent. Okay, all right, so let's do the domain and range of this beautiful one here. What's the range of this one?
Negative to infinity.
Negative 2 to...
Right, let's go.
Miss Guy, did you write the ordinance backwards?
Yep, I totally did.
Yeah,
Yep,
I was wondering, I wrote mine down opposite.
good. So you guys know what you're doing. I was just being cocky, and that's what happens. Think I know what's going on, and then I write it backwards. Okay. All right. Now let's talk about our graph. Let's talk about our graph. What can't exist?
Negative y value.
All that underneath there can't exist, right?
So would it just,
Ooh. So let's talk about... Nope.
is our range gonna start at 0?
This is what... Yeah, our range will start at 0.
So it's just 0 to infinity?
So these are going to end up going out like this.
Why?
Well, if we want to do the table of values and we square root them, they're going to end up just like this one flattened out. These ones are going to flatten out. Yeah, you're going to probably have to draw these at some point.
How do you know
Is
that?
that a challenge?
So we do have to do the whole thing?
Okay, remember how when we did the cosecant graphs and the secant graphs, it was like you did the parabola and then it opened up, and I gave you guys some values to show you how it worked, and you guys said, do we have to graph those values? And I said, no. And you guys, okay, so I just need to know that this parabola opens up and this one opens down. Same sort of thing happening here.
Can you know some other paper then? Like,
What?
like, you know, when you gave us a paper of the graphs,
Uh-huh.
chapter?
I can give you the table of values that goes with that after, if that's going to be helpful.
What's the difference if it like goes?
How would you give you every single graph that's like that?
Okay. I can't give you every single graph because all the values will be different based on the table of values. Like this function won't have the same graph as the other one, the cosecant graph did.
Yeah, just give us guess1.com.
Okay.
Okay, how would we do the table of values then?
We'll do the table of values for that parabola. Square root all your y values. Okay. So we know that we have 0 and negative 2. Right? We know that that's our parabola. If we put in 1, if I put in 1, it's going to have a value of negative 1. If I put in negative 1, it'll have a value of negative 1.
Why?
Because I'm substituting it into the equation.
We too fast.
That was root negative y values, right? For every-
I know, but I'm doing the original function, and then I'll do the radical function. She wants a table of values. I'm doing my best.
Okay. Giving the people what they
I'm giving the people what they want. Yeah. Okay, let's go to negative 2. If I substitute negative 2 into that formula, what do I get? 2. And if I substitute in positive 2, what do I get? 2. Okay. If I put in negative 3,
No, I'm not going to. I don't know the room. 7.
7. Positive 3. 7. Okay, Amber is on a roll with her substitution. We're substituting into this one. Okay? All right. So negative 3. What's my y value on the rooted graph? Root 7. Yes. It's that. It's literally, it's just that. What happens? What did we say can't exist? We can't do anything with those. So at negative 2, root 2. At negative 1, at 0, sad face.
It looks like a complex mathematical symbol for an imaginary number.
Okay. So the root of, so at negative 2, we're going to be at root 2, which is shorter. We all agreed that that's less of a value than 2, right? We know that root 2 has to be less than 2. Right? We all agreed to that? So that's why these values are a little bit shorter and they end up going out weird like that. Okay. Let's do the range. Let's do the range because that's nice. Where does my range start? 0. Where does it go to? It's just going to take longer to get there because it starts off significantly shorter, right? Okay, so remember piecewise functions?
No. This guy, I didn't even understand those notes. I love it. I don't know how you're
What? The ones that we had to split, right?
Yeah.
Right?
I remember like you
They
so
were
many
not-
notes about those.
Is that the one that has like the U in the middle?
Yeah. Okay. All right, ladies and gentlemen. What do we notice? We notice that there's a big break in our graph, right? Big break in our graph. I can't have any domain values between negative root 2 and positive root 2 because those would all be negative y values and I can't have that. Those do not exist. So they're the sad faces on the graph. So we're going to talk about this arm of the function. Okay, you got 2 arms. Yes, it's the u. So let's talk about
With no stick.
with no stick. The u with no stick. See, I did teach you something. We're going to talk about our left arm first. So tell me about the left arm. What's the domain of the left arm?
Oh, so it is unison.
And it's a square bracket because it includes that because that's a 0 there. So in unison with, let's talk about the right arm.
Is it not just root 2 to infinity?
Yep.
Why were these so difficult last?
It was so hard.
I got them wrong in every single test.
Nope, that's piecewise. You had to pick which part was part of the absolute, which did you flip, and which stayed as the original.
But there was like harder than just looking at the graph and just doing
I got
that.
the
No, that's not what you had to do with the piecewise. Okay.
Wasn't there like another one where it was like
Yeah, that was the hump. You were, see, Turth, you missed all these good terminology. We had 2 arms or we had the hump. Which one did we flip for our absolute value graph? So the hump had the less than and equal to sign in it. Okay. Whew. We're going to get through this lesson. Okay. All right. These are, hi. These are your steps. Super important. Locate the invariant points on the original graph. We've talked about where they are. They're when y is equal to 0 and y is equal to 1. Okay? And really, what are these? These are your x-intercepts. Okay, so that's what we're going to do first. So we're looking at this linear graph down here. And my x-intercept is at -4. So that's really important. And what's my next really important one? -3. Because what's the y value there? Those are two really important points because those are our invariant points. And what happens between those two things? The bubble. Those are your bubble points. Because that, I looked at the, well, I didn't look at the line. Somebody looked at the line and said, well, at -3, I have a y value of +1, and that's an invariant point. Okay? So really it had less to do with the x's and more to do with what the y's were doing. Right? Okay, good job. Locate any other key points on the original graph where the values are greater than 1. I might graph this point. Why would I graph this point? Because it's what value at this point is 0 and 4. So what's going to happen to the y value? It's going to square root, and it's a nice perfect square, so where's it going to go? It's going to go to 0 and 2.
So we don't need to do a table of values.
No, you don't.
Wow.
You
I
don't.
look at this point in math.
You don't need to do a table of values, but you do need to do a point beyond the two invariant points. Okay? So you need like a third one.
Just one?
Just one.
Okay.
So let's graph it. Okay, so we have the bubble between our two invariant points, and then we go through the rooted point. And again, pick a nice point that you know and you're comfortable with the values of. Okay, that's it for drawing radical graphs of given functions.
There's one more.
Don't cover that.
What do you-
No, there's one more example, I know that.
Oh, okay.
Okay, all right. Okay, so what are my key points? So are these ones nice? Do I care? I don't. Oh, sorry. I mean, I do. I do care, but I don't even have to label them. So where's my next favorite points? So I did the y equals 0 here. The next point is going to be at 2, 1, and then -2, 1. So if I was graphing this on a test, I've already labeled my 2 points. If this was a question just saying graph the rooted function, graph the radical function of this, I only have to label 2 points on my graph, so I picked ones that were easy. And I didn't have to solve for my x-intercepts or worry about those. Do you get what I'm laying down here? Like, make it easier on yourself. We don't need to calculate them. We don't have an equation for this. So now we're going to graph it. What's a point that I'm going to graph that will be nice?
We can't use four.
Well, I can.
But look here. Oh, wait.
So it's right
Oh,
there.
yeah. Okay, never mind.
So it's like 3 and a little bit,
Yeah.
3 and something, and 4.
When we're graphing it, I guess it doesn't matter.
So 3 and a little bit, and 2. Why did I do that one? Because it was a y value of 4. So what's the square root of 4? What? This one here? That's part of my root. So I knew that this y value was 4. I don't know what the x is. It's like 3 and a little bit. Like I don't actually know what the decimal is. But really, what am I concerned with? The y value. Sorry, this should be x. Oh no, that was for this point right here. That was for that point. So now this one is going to bubble up between my two invariant points, and it's going to go through my third point. So there's that point on this graph. So bubble and through. And I've just graphed my two radical graphs without a lot of math attached to it.
Can you do that on a test? You don't need to.
Oh no, I'm probably going to give you the equation where you actually have to find the x-intercepts and ask you to do the domain and range. So this question didn't ask about the domain and range. If I needed the domain and range here, I would need to know where my x-intercepts actually are, because those are part of the domain.
So we're not gonna do this.
So why didn't you do this?
Well, but it just shows you how easy graphing it can be.
So rub it in last year you wanted us to scribble out the non-existent part. You
No,
wanted us to do that?
you don't have to do that. Because you are graphing, like this is already graphed for you, and then you're just doing another graph on top of it. Last year you were doing an absolute graph.